In this tutorial, I'll introduce Duet modules and demonstrate how their use significantly simplifies programming tasks. I'll provide a basic overview, look at the module as a device driver and translator, the Snappy router as the bridge between Netlinks and Java, the role of the virtual device, and virtual device addressing, the module in lieu of the real device, serial and IP. You're probably familiar with the term driver files. Driver files are used in the realm of personal computing to run peripheral hardware devices. For example, when you buy and then install a new printer for your PC, you typically need to download and install the driver file or files for that particular brand and model printer before it will work. In addition, once the printer driver is installed and working, other applications on the computer can then interface with the driver to access the printer. Similarly, in the AMX world, a host of device drivers for most AV-controlled devices are available for download from the AMX.com Tech Center. Those drivers or modules, in AMX terms, can be implemented in Netlinks workspaces to drastically simplify programming tasks. Therefore, AMX module is a generic term used to describe a file or files of pre-written programming code used to control a specific device via the Netlinks system. The module translates standardized snappy commands into the string data that a particular device requires. If you change devices, you can simply replace the module with the new module, and the snappy commands in the source code will work with the new device. The module may be a single file or several files used together to interface with an external device. TechNote 651 addresses the scenario of using several files to control a device. Within this generic term, there are several types of modules including Access, Landmark, Netlinks, Duet, and Standard Netlinks. These types are differentiated by the series of AMX equipment you are using. For example, Duet modules will only run on Netlinks masters with Duet firmware. Let's break that down. Modules help with serial and IP control. Serial and IP control involves using API commands to execute functions on a controlled device. For example, to instruct a disk player to start playing when the play button on the touch panel is pressed, a Netlinks controller must have been programmed to send out the required control string to the device. That all seems reasonable enough at first. However, differing manufacturers and device models typically don't speak the same language. So if we were to swap out the disk player in this example or reuse the code for subsequent projects, we'd have to rewrite the code to accommodate the new device API. And that sounds a bit like reinventing the wheel. Hence the role of the COM module. The COM module in process sits between the master program and the controlled device. It contains the device-specific control code required to communicate with the controlled device in its own language. And on the other side, the module interfaces with the code file or files using the Snappy protocol. Hence, a key role of the module is that of translator for the programmer. The programmer writes the code for the corresponding Snappy device type, and the module translates the Snappy interface into the device-specific API. One final part is still required to complete this interfacing module. The COM module itself is an independent file, limiting the scope of the source code to within itself. All code, including subroutines and variables, can only be accessed from within the file itself and not from the master nor any other files. Also, today these modules are Java files, written and compiled in the Caffe Duet environment and not in Netlinks Studio. So for the programmer to be able to interact with the module, a bridge is provided in the form of a virtual device. The virtual device, like an actual physical device, has global scope and can be interfaced with by any and all program files and their parts. Now the programmer writes snappy code to interface with the virtual device. The module file watches the comms into the virtual device and reacts accordingly. The same applies in the other direction. The module translates feedback from the physical device and directs it towards the virtual device. the master file or files watch for the comms associated with the virtual device and in turn process the feedback. To create a virtual device, the programmer need only define the virtual device within a specific range. From the device addressing table, the address range for Duet virtual devices is 41001 to 42,000. The device table is referenced in several previous tutorials and is included in the course materials that are available in the resource folder. Also, the module interface model shown here is always referenced in documentation that is available along with the module itself in the AMX.com Tech Center. I'll revisit these references later on in this tutorial. So for now, by defining a virtual device in this range, the controller knows to create a virtual device for use on the NetLinks bus. And by the process of using a module, the programmer can ignore the physical device and its specific API, and concentrate solely on the virtual device and its relative SNAPI by device type. In the next tutorial, let's implement a module in the code.